on page 97, it starts with the high pressures and low pressures and how they affect South African weather. And I think this is quite important. So I've taken a picture from your textbook of page 97, and there are just a couple of things that I'd like to talk to you about. First of all, there are these massive pressure belts, 0 degrees, 30, 60, 90 degrees. At the equator, it's a low pressure. Then at 30 degrees north and south, there's a high pressure. And this is where we have 30 degrees south going through South Africa. We are 30 degrees south of the equator. So we have these three major anticyclones, which are high pressures affecting South Africa. Now, you have to understand that in a high pressure, I have subsidence. Any moisture will evaporate, and therefore I will have heating. So I'm going to have stable conditions and no rain. That is why we have this whole area as a desert, because there is no rain. Because these high pressures, I have subsidence, and as the air subsides, it heats up and all moisture is evaporated. I also have this warm Mozambique current, and that's why Durban is so nice and warm, and there's not much difference between winter and summer temperatures, because this warm Mozambique current, lots of moisture. But on the west coast, I have this cold Benguela current, and that is why I have very, very little rain, because if air is cold, it cannot rise, and I need air to rise, to cool, to condensate. So how does this affect South Africa and its temperatures? So firstly, here's the plateau going down towards the sea, and let's say this is Durban over here. And Bloemfontein will be up here on the plateau. So because in winter there is this high pressure that I showed you in the photograph, plus it is cold. So I have chronic subsidence. Air moving up from the sea cannot get onto the plateau because this high pressure is subsiding, stopping this nice warm air. As a result, in Bloemfontein and along the entire plateau, so here's South Africa, and here is the Drakensberg, so this whole area is the plateau, will not have rain in winter. But in summer, I'm going to draw the plateau again, but in black. Here I have the sea. Here is Bloemfontein. I have this high pressure. I still have this high pressure, but it's a lot weaker because it's in summer. So it allows this air to move in. Air that rises, it's warm, it will cool, it will condensate at dew point temperature, and I will have rain on the plateau. So Bloemfontein will have summer rainfall because this high pressure then will lift. What happens? High pressure, and you must know the names of these high pressures: the Kalahari high pressure, the Atlantic high pressure, and the Indian high pressure. Now these pressures move because in winter, when the sun is shining over the Tropic of Cancer further up, these high pressure belts will move up, and when the sun is shining over the Tropic of Capricorn, these pressure belts will move down, and they move. So let's say I have a mid-latitude cyclone that moves in. They move from the west to the east, and please, you need to know about your mid-latitude cyclones. This is a low pressure, and quite often this high pressure might move further up. So I'm going to rub it out. This low pressure might sometimes develop over the land, and what happens is this high pressure, because air is moving from a high pressure anti-clockwise into this low pressure clockwise, it actually ridges. It's called ridging in because it's feeding this low pressure with air. That is called a cut-off low, and this will cause a lot of rain. So very, very often you'll hear about a cut-off low and the high pressure ridging in after. It's quite nice to have a look. You should call up a synoptic chart. You can go to South African weather and have a look at a synoptic chart, and you can see where these high pressure belts are. If there's a mid-latitude cyclone, tropical cyclone, I'll do it in green, you can only find here, if there is one, low pressure. And it's quite interesting to see what's happening in the United Kingdom at the moment with a very, very low pressure, high winds, and flights have been cancelled, and torrential rain because of very low pressure. Air moving into this low pressure from a high pressure, creating lots of rain and lots of wind.